Hello everyone, welcome to Bright Engineering. Today we are going to look at complex numbers, and then with complex numbers we are going to look at the division aspect of complex numbers. So when you have a complex number dividing a complex number, how do you go about it? So first and foremost, when you get a complex number like this, the first thing that you have to do is to conjugate the denominator. I know that the first time you heard of conjugation was probably during set or something. So for complex numbers, the conjugation of the complex number only happens to the imaginary part of the complex number. So when you take this question and you take the denominator, the imaginary part is the one with the I, the one with the I. So minus I is the same as minus 1I. So when we want to solve it, it means that we have to find the conjugate of this part and multiply it by the expression. So on solving this, we are going to get the conjugate of 3i to be root 3 plus I. Right, so this is the conjugate. And then multiplying by the expression, we are going to get 9 root 3 plus 9i over root 3 minus I. The same, we are repeating the question, times root 3 plus I over root 3 plus I. So we've not done anything to it, because what we are doing here is just that we are just creating and then destroying. So straight away this can just cancel this and it will look like we've done nothing to our question, right? So now let's expand and see what we get. So on expanding this, we are going to take the first term to multiply these two and then the second term to multiply these two. So 9 root 3 multiplied by root 3 is going to give us 9 into brackets 3, because this is going to give us root 3 squared, and the squared is going to take away the root sign, and this multiplied by this is going to give us plus 9 root 3I. Multiplying this by this, we get plus 9 root 3I, and multiplying 9I by I, we are going to get minus 9. So you get confused why we are getting minus 9. Note, I in complex numbers is the same as root of minus 1. So when we have I squared, it means that we are getting root of minus 1 squared. This square will take away this root sign, and then we are left with minus 1. So when we have I squared here, because we are getting I and then I multiplying together, so we get I squared. And that squared is going to change this sign, the positive sign, to a negative. That's why we have minus 9 here. I hope you get it. We are going to get the denominator as the same thing, so we are going to expand it. So here we are getting root 3 multiplying by root 3, which is going to give us 3. Root 3 multiplied by I, which is going to give us root 3I, minus I multiplying root 3, minus root 3I, and then minus I multiplying I, which is going to give us minus I squared. But then I squared is going to give us negative 1, so we get plus 1. Now let's group like terms. So here we are getting 9 times 3, which is 27, and then we are getting minus 9 here, plus 9 root 3I plus 9 root 3I. So because they are same, we can just add them, getting 18 root 3I divided by 3. This will take away this because they are the same, and then they have different polarities or different signs. So we are getting 3 plus 1. And now our answer is going to be 18 plus 18 root 3I over 4. So let's look at something here. When we conjugated the denominator and then multiplied it, we noticed that this one took away this one, and we were left with just 3 and then I. So it's the same as multiplying the first term by the first term. So please let's look at something. We are getting root 3 minus I times root 3 plus I. So now let's multiply just the first terms and the second term. So root 3 times root 3 is going to give us root 3 squared, and minus I plus I is going to give us minus I squared. So this is going to give us 3. This is going to give us minus of minus 1, which is the same as 3 plus 1 is equal to 4. So whenever you conjugate a complex number, don't waste your time expanding it like you do with the numerator, but straight away you can just multiply the first terms by the first terms, and then the last term by the last term, right? So this is what we are getting as our answer. And then straight away you can just expand this to get 18 on 4 plus 18 on 4 root 3i if you want, but then any of these is correct. Thank you very much, and don't forget to subscribe to Bright Engineering.